same amount of heat, they are warmed differently. Like for example, you go to a beach. Sun's rays are falling equally on the sea and on the land surface. But why both of them are warmed differently? The land will be more warmed as compared to the sea. They are two different materials. Both are getting warmed differently. So we'll be learning about different materials. Some of them are good conductors of heat. Some of them are bad conductors of heat. So based on whether a given object will be conducting heat or not, upon that basis, there are some objects which are good conductors while some are bad conductors of heat. We'll be learning about that. Okay. Now, among the cold objects, some may be colder than the other. While among the hot objects, you have two hot objects, A and B. One of them will be hotter, one of them will be less hotter. So how do we do this comparison? How are we going to decide the relative hotness or coldness of objects? We can't simply rely upon the sense of touching. Like we can't go on to touch everything. Our hands might get burned sometime. So how do we define how hot or how cold a given object is? Getting it, guys? So our discussion will be based upon all these things. Okay. We'll be learning about temperature, what is thermometer, what are different types of thermometer, why we use mercury in a clinical thermometer, what is the use of the kink constriction in the clinical thermometer. Getting it now? Then we would be learning about like in the meteorological stations, like when weather reports are made, there also we have to take help. We have to rely upon the temperature, the highest and the lowest temperature of the day, in order to come up with the weather forecast. Getting it, Abu Bakr and Gauss? We'll be learning about how to take reading using a clinical thermometer and a laboratory thermometer. What are the things we have to take care of? What is the range of those thermometers? Okay. And later on, we'll be learning about the transfer of heat, how heat flows from a hot object to a cold object. So first of all, talking about heat. So when a hot object and a cold object comes in contact with each other, so thereby a type of energy flows from one body to another. Like if you were to hold some ice cube in your hand, do you not feel like there's a flow of something in between the ice and your hand? You feel something is flowing, like so some form of energy flow is taking place there. So there, what is happening? Basically, the heat from our hand is lost into the ice cube. Basically, heat travels from our hand into the ice cube. Getting it? So whenever a hot and a cold object will be coming in contact with each other, a type of energy flows from the hotter object to the colder object. That is the reason why our hand feels cold when we hold a piece of ice cube in our hand, because the energy, the heat energy is lost from our hand into the ice cube and not the opposite. Getting it? Why we feel cold when a ice cube is placed? Because energy is lost from our hand. That ice cube basically absorbs the heat from our hand. Okay. So this energy is basically heat energy. Its SI unit is joule. It is measured in the unit of joule. What is the bigger unit? That will be kilojoule. Okay, now kilojoule is basically 1000 joule. In short, is called as kilojoule, and kilojoule in short is written as capital K and J, like this. Earlier, calorie was the unit in which heat was measured. Okay, now earlier the calorie was the unit in which heat was measured, but nowadays when the SI units were developed, okay, now like when the SI units were developed, then this unit was adopted. Getting it? Like SI unit, we know that it was the, like we have different things, like mass of different objects is there, heat given out by the object, loudness of different objects. So in order to measure different quantities now, a standard system was developed. Getting it? So that was SI unit. That is International System of Unit. It was established in the year 1960. In 1960, SI units were developed for the first time. And this is the modern system of measurement. Okay, now getting back to the discussion. So we are learning about this. Then talking about hot and cold objects, how do we really decide whether a given object is cold or hot? So one thing is obvious, like you can see that I can go on to touch the given object and I will be able to decide whether it is correct or not, or whether it is hot or warm. But we can't always rely upon our sense of touch because it can deceive us sometimes. Yes, Priyanka, Abu Bakr, and Gauss, you guys
Yes, sir.
might have learned of this activity. Gauss, have you learned of this activity?
Yes, sir.
Mhm. What happens in this? We had taken three containers, water containers. In the first one, cold water is put. In the second one, hot water. While in the third one, lukewarm water is put here. Normal water. So we have dipped the hand in container A. So our hand will be feeling cold, and this hand will be feeling warm. But when we dip this hand into the container C now, there it will be feeling warm. And when we put this hand in the container C, it feels cold. Why does that happen? Hmm? Getting it what I'm trying to say. Say that this was the this container contain cold water as per the activity. This has cold water, this has hot water, and this has normal water. So when you dip your hand in container A, your hand will be feeling cold, obviously, right? So what is happening here? The heat is traveling from the hotter body to the cold body, as we know. So heat is traveling like in comparison to the water. Your hand is warm now. If you were to compare your hand with the temperature of water, your hand is colder. I mean to say warmer. So heat flows from the hand into the water. So that's why your hand feels cold. But once you dip it into this now, so thereby now, while you had dipped your hand in container A, your hand became cold. But in comparison to this normal water, right now your hand is cold now. Cold hand, and this is normal water. But if you were to compare the temperature of the cold hand with the normal water, which is more warmer, it is water that is more warm, and we know heat flows from a warmer object to a colder object. So thereby now in this case heat was flowing from the water into the hand. That's why our hand felt cold. But is the water cold here? Priyanka, Abu Bakr, and Gauss, is the water cold here? Is the water warm? I mean to say, no. Water is normal now. So you dip your cold hand in container A. Now you are dipping the same hand in container C, which contains normal water. So this water is normal. Its temperature is normal, but it feels warm. Why? Because there's a flow of heat taking place from the water into your cold hand. Because water is warmer as compared to your hand. Have you understood this, Gauss?
Yes.
Now talking about the hand put in the container B. So you had put your hand in the warm water. Note, make sure that this water should not be so hot that it burns your hand. So we have put this in this. So now here what is happening? Our hand feels warm. Our hand feels warm. Why? Because the heat is flowing from the water into the hand. There's a flow of heat taking from the water into the hand. Okay. Now your hand has become warm because you dipped it into the warm water. So when you are dipping your hand into this normal water, there what will be happening? The water is normal and your hand is warm. And what do we know? The heat flows from a warm body to a cold body now. So heat will be flowing from your warm hand into the water. The heat flows from the hand to the water. So thereby your hand is losing the heat. So this hand will feel cold. But is the temperature of the water cold? Is the temperature of the water cold here?
No, sir.
No. So here our sense of touch is deceiving us now. It was okay in container A and B. You're able to sense it properly, but in the container C, it is deceiving us. So thereby, sense of touch is not always a reliable way to measure the hotness or coldness of a given object. So thereby, we have to rely upon a device called as thermometer. Okay. Also, we need to know what is temperature. So temperature is nothing, it's the degree of hotness or coldness of an object. Talking about thermometer, it's a device that will be used to find out the specific temperature of a given object. Okay, now so there are different types of thermometer. Okay, now based on our use, there are different types. If you are going to use it for clinical purpose or to take the temperature of the body, so we are going to use this clinical thermometer. Okay, we have to use this clinical thermometer here. Talking about the structure of the clinical thermometer, so one has a this one has a hollow cylindrical this has a thin hollow cylindrical pipe running inside and which is filled with mercury. Okay, and mercury is stored in this bulb. This structure, as we know, this is called as bulb in which the mercury is stored. The principle of the use of why we use mercury in this now, because mercury expands in a uniform manner upon being heated. Okay, like every time, let's say you heat the mercury to 30 degrees Celsius. Okay, or let's say you heat the mercury to 40 degrees Celsius. No matter how many times you are going to heat it to 40 degrees Celsius, it will always expand in the same manner, in a uniform manner. Let us say you have taken a container, we have taken several containers of same size, and each of them, let us say, contains some mercury. Each of them contains mercury, and you are heating all of them, to a equal temperature of 40 degrees Celsius. Here also you are heating it to 40 degrees Celsius, here also 40, and here also you are heating it up to 40 degrees Celsius. So each time what you will observe, that the level of mercury in these glass tubes will be rising to the same height. Let us say they rise up to here. Okay, they are rising up to here. So what do we observe here? That they are rising in a uniform manner now. Can't we conclude this thing? Yes, was Priyanka, Abu Bakr. Can't we observe this thing here? The mercury is rising in the uniform manner in each case. That's why mercury is preferably used in a clinical thermometer, right? So this is the most commonly used thermometer, and there's a narrow tube inside this which is filled with mercury. And basically, mercury will be filled in the bulb. Okay, whenever the temperature of the body will be taken, so the mercury from it will start to rise, it will start to expand, and wherever it will be stopping, it will give the reading of the body. So right now, like here, it has stopped at 37 degrees Celsius. So that's the body temperature, and that's also the normal human body temperature, as we know. Also, this has two scales of measurement. One is the Celsius, another one is the Fahrenheit scale. Okay, that is the thing about the clinical thermometer. Now, moments ago we were learning about mercury. So you can see the mercury here. It's a shiny silver white metal. Also earlier, it was called as quicksilver. Okay, now it was in ancient time, in olden time, it was called as quicksilver, and it exists in a liquid state at the room temperature. It is used apart from the thermometers, apart from the glass clinical thermometer. It has several other applications, like it is used in the compact fluorescent lamps also. In CFLs also it is used. Okay, now although CFLs are no longer in use, but earlier while it was in use, it was used there. Apart from its use, we have to be careful around mercury. Why is it so, Abu Bakr? Why we have to be careful with mercury? Yes, Gauze, you tell me, or others, why we have to be careful with the mercury metal. Yes. If you guys
Yes,
can,
because it can be irritated to or that
it can be.
it can be irritated to skin.
It can be irritative to the skin. Not particularly, it can be irritative to the skin. Okay, now if it is exposed to the skin for a very long period of time, then it can be irritative. But usually no. If you were to, you can like hold it in your palm like this, as the person is holding here. The thing is that it's toxic in nature. Abu Bakr and Prinka, you guys forgot about this? Huh? We did. I did told you guys in the class while the chapter was going on that it's toxic in nature now, right? Getting it? Or if someone, some children were, or some people were to accidentally engulf this now, it can damage their kidneys, their lungs. Okay, even it can damage their nervous system in the body. Getting it now? So thereby one should stay away from the mercury, and its use in clinical thermometer should be discouraged. In fact, it is no longer used in the clinical thermometers. Nowadays, we have got the digital thermometers. Okay, now, so that is the thing. While handling, we did learn about why mercury is used. Okay, now, like we did learn, upon heat, upon being heated, it expands. And how does it expand? It expands in a uniform manner. It expands uniformly. That is the reason why it is used. In fact, it is the only metal to exist in the liquid state at room temperature. Apart from mercury, there isn't any other metal that exists in the liquid at room temperature. Getting it? Why we are talking about room temperature here? Okay. Like mercury around the room temperature, it will be existing in the liquid state right now. But for some other metals, you have any other metal that will not be existing in the liquid state at the room temperature. Like for example, the melting point of iron is very high. The melting point of iron is very high. Like you have to heat the iron to about 1500 degrees Celsius. Then only iron will be melting. So will the temperature of the body ever go to 1500 degrees Celsius? Just suppose like if I were to use iron in this in place of mercury, I were to fill this with iron. So iron will start to expand, it will start to melt once it has been heated to a temperature of 1500 degrees Celsius, about 1530 or 38 degrees Celsius to be exact. So the temperature of the body never goes that much. At that temperature, the person will not be alive. Okay, he will be basically evaporated at that temperature. Nothing will be left. But mercury will be basically converting into liquid state once it gets the temperature of just 38 degrees Celsius, just slightly above 37. Getting it now? Also, when a person is suffering from fever, so how much the temperature of the body goes? It is around 100 Fahrenheit, 101 Fahrenheit. That is about 38, 39, 40 degrees Celsius. Not beyond that much. Getting it now? So that is the reason why mercury is used and not any other metal is used here. And what are the precautions one has to take care of while they are using a clinical thermometer? Okay. Like the first thing is that we should handle it with care since it is made out of glass. Then we should be washing it with a antiseptic solution. In case antiseptic solution is not available, we can simply wash it with a clean water. We should hold it gently, and we should, where should we holding it? Should we hold it by the bulb, or from its body? Why we shouldn't hold the bulb of the clinical thermometer? Why? Say that this is the bulb of the clinical thermometer in which mercury is stored. Why shouldn't I be holding this? In order to take the temperature of the body, while I am holding a clinical thermometer, I should not touch the bulb here. This is the front part in which mercury is stored. Yes, Abu Bakr and Gauss, why shouldn't I hold it? Mhm. Okay, let me answer. The thing is that the bulb of the clinical thermometer is very sensitive towards temperature. Okay, now it's very sensitive towards temperature. Getting it? So say that you have taken the temperature of a person suffering from fever. Let's say the temperature of the person's body is around 100 degree Fahrenheit. Okay, now you took the reading of a person, the temperature, you saw it to be 100. But as soon as you are touching it with your hand, now, let's say the temperature increased or the temperature decreased. Temperature might increase to, let's say, 101 Fahrenheit, 102 Fahrenheit, or the temperature might decrease. So your reading is now wrong now. Your reading has been disrupted. Getting it? The person might not be having that much of fever, but accidentally you might increase the dosage of medicine. So that will be problematic for the person. So that's why we should never touch it with the bulb. Also, we should be keeping it at the line of sight, like over here. In this manner, I should be reading it. Not like this, not like this. Getting it? Is my video visible to you guys or not? Yeah, it is. So that is the thing here. Okay. Also, one must, before we are using this, we must give it a slight jerk like this. We must give it a slight jerk so that if the mercury is somewhere here or here, so that it falls back to the bulb. It falls back to the bulb and we are able to take the proper reading. That is one thing. Now, while we were looking at the structure, there was a very important thing in the clinical thermometer. Like you would have noted a kink here. It's not visible in this diagram, but there's a constriction over here, like this. Okay. Abu Bakr, you explain the role of this constriction called as kink. What is its role? Yes, Gauss, if you know, you can also explain. What is the role of the kink in a clinical thermometer?
Sir, sir, the kink prevents the mercury level from falling on its own. So, like, if you have taken a temperature and the kink was not there, the mercury can fall back on its own.
Okay. Abu Bakr, you also explain this?
Sir, it is to prevent the prevent the
Okay. Very good, both of you. Okay, no, very good. Very well explained. So basically, this kink prevents the mercury level in the thermometer tube from falling on its own. Prevents it from falling back to the bulb. That is the thing here. Okay, now moving on to the next thermometer, we have this digital thermometer. Okay, now how does this work? So it has a light sensitive chip in it called as thermistor. That is fitted into the bulb. It doesn't work using the mercury. Getting it what I'm trying to say? So there is a thing called as thermistor which is fitted in the laboratory, which is fitted in the digital thermometer. Getting it? And this thermistor is used at so many places. Like in air conditioners, also this thermistor is used in refrigerators, in fire detectors. There also it is used in even in the microwaves. Also it is used right now. So how the air conditioner is able to tell you the room temperature? It is because of the thermistor installed in it. So it will be detecting the surrounding temperature. It is used in this digital thermometer also. So nowadays we prefer using this. They work on tiny dry cells. Tiny dry cells of circular shape are fitted in this, and they are safer because they do not use the toxic substance that is mercury. That is all about digital thermometer. Nothing too technical about it. Okay. Talking about the laboratory thermometer, this is especially designed for taking the temperature of very hot or very cold objects in the chemistry lab. Okay, now. So this is a device which is used for measuring temperature in science laboratory, and thereby it is called as a laboratory thermometer. This is made out of a long glass tube which has a very thin bore in it, thin capillary tube. This is the thin capillary tube, also called as thin bore. Okay. That is the thing. Also, the range of the temperature marked on this laboratory thermometer is from minus 10 degrees Celsius to, if I were to zoom it, you can see it here, minus 10 degrees Celsius to 110 degrees Celsius, right? So it can determine, it can measure objects ranging in between this temperature. Okay. Also, another important thing is that if you were to look at the structure, it doesn't have any kink in it. So since it doesn't have any kink in it, so while you are going to take the temperature, it has to be kept dipped into the solution in which you are taking the temperature. So it has to be kept dipped into that solution, because the moment you take it out, the mercury will start to fall back to the bulb and your reading will be wrong. So while you are going to take the reading, it has to be kept vertically held above that solution. Okay, now also you have to, like, if the temperature of the given liquid is very hot, so you have to take help of a holder. So we can use a holder to hold this. That is one thing. So what are the precautions we have to take care of? We should be handling it with care, obvious thing. Do not hold the thermometer by the bulb. So you should not be touching this part. You should hold it vertically. It should be kept upright and should not be tilted. And the bulb should not touch the surface of the container. Like this should not be touching the surface. Otherwise, the reading might be disrupted, or the laboratory thermometer might break since it's made out of glass. While removing the thermometer from a boiling water bath and immediately immersing it in ice bath may cause the thermometer to break. Say, for example, this is a boiling water in which you had dipped the laboratory thermometer. If you were to take it out from the boiling water and if you were to immediately put it under ice water, very cold water, so because of that, it will break up now. It will break down. Getting it?
It
So
is not only for the uh, for the thermometer. Actually, it is also for the case for like glass, normal glass.
for normal glass also, very good, no? Very good. Like for example, you had no put some hot water in a cup of glass. Okay, then take out that hot water and put cold water in it. Okay, it should be very cold. That glass will break. So same thing goes for this object also, since it is made out of glass. Okay. Now, why this laboratory thermometer is not suitable for measuring the body temperature? Huh? Why it's not suitable to take body temperature using laboratory thermometer?
So because it does not have a kink near the bulb, and um, it can't prevent the mercury level from falling back on its own into the bulb.
Exactly. That is the reason. Okay, now, like it hasn't been designed to measure the body temperature. Okay. It has been specifically designed for laboratory use and it lacks a kink. Thereby, it prevents like we know, kink prevents the mercury from falling back into the bulb, right? But it doesn't have. So even if you were to use it for a person, so the mercury will immediately fall back into the bulb. Thereby, our reading will be inaccurate. Okay. Then talking about why we can't use the laboratory clinical thermometer. Huh? Why can't we use clinical thermometer in laboratories? Yes, Priyanka, you back in the class? Hmm. My question is why this clinical thermometer, which we had learned about moments ago, which has just a range of 35 to 42 degrees Celsius, right? It can measure temperature between 35 to 42 degrees Celsius only. So why we can't use it in a chemistry lab?
So because if the solution or the water which you're measuring it with, if it's too cold, then it will break. If it's too hot, it will break the thermometer. Uh,
Exactly. Mhm. Right now, so the clinical thermometer, it might break if it is exposed to very high temperature. Okay, no? So that is the thing. Since it has a very its a range is very concise. Okay, it has a very small range of temperature which it can measure, and is only between 35 to 42, which is not suitable for measuring temperature of chemicals or solutions in a lab. That could be very hot and that could be very cold. So that is the thing here. Okay. So we had learned about these things so far. We did learn about the precautions. Here in this image, you guys can see how it has been held in an upright position, in a vertical position, and not in horizontal or not being tilted. That is the thing. Apart from these thermometer, there are some other thermometers also by the name of maximum and minimum thermometer. So these temperatures are designed to measure the maximum and minimum temperature throughout the day, especially being used by the weather forecasters. Okay, look at this one. This one is the modern version of a maximum and minimum thermometer, right? So it is designed in such a manner that it can record what was the highest temperature and the lowest temperature that went over in a given period, in a given day. Okay, like have a look at this weather report. So this shows you the maximum and the minimum temperature throughout the day. Like here you guys can notice that the maximum temperature that went on that particular day over the past 24 hour was 27 degrees Celsius, right? And the minimum temperature was 21 degrees Celsius. Getting it now? So daily weather reports, apart from the from the temperature, it carries some other things also, like what are the chances of rainfall? Like there's a 37% chance of rainfall. Okay, 11% clouds are there in the sky, right? What is the direction of the wind? What is the speed of the flow of the wind? In which direction the wind is flowing? So all these things are mentioned apart from temperature in the weather report. Okay, you guys answer this question and then we'll be continuing next.
Sir, in chat box.
You guys have to answer in the chat box. By the way, in the chat box goes now, whenever you will be required to answer, you will be answering on this ID. Okay. And not the other one, because I will be able to see from this one only. Okay. If you see in the chat box, I have joined from Tori. Okay. Huh. Yes, that is correct, Priyanka and Gauss. Second one, that is also correct. Both of you. Yes, Abubakar. That is correct. Very good, Abubakar. By the way, we humans, are we cold-blooded animals or warm-blooded animals? Yeah, for the third one also correct. Yeah. By the way, we are warm-blooded or cold-blooded animals? Yes, what do you guys think? We are warm-blooded animals. Yes, Gauss, correct. Okay, na? So what? Yes, Abu?
Sir, what does it mean, warm-blooded or cold-blooded?
Let me clarify it. Like warm-blooded animals are those animals who can survive, like they will be able to survive in the different climates. Why? Because they can maintain their normal body temperature. They can maintain their normal body temperature, hence they are able to survive in the changing climates. Getting it? But we have some organisms who are considered as cold-blooded animals because they can't adjust their body temperature in according to the surrounding. Like in the summer season, we'll be sweating a lot. Sweating helps in cooling down the body and maintaining the normal temperature of the body. Getting it? In the winters, our body produces more heat, and we are able to maintain the normal temperature of the body. So we are able to survive in summer and in winter both. But there are some organisms, particularly some small creatures like insects. So they will not be able to survive in winter because they can't adjust their body temperature according to the changing temperature of the surrounding. So on that basis, they are warm and cold-blooded animals. Getting it?
Sir, they cannot sweat.
They cannot sweat also. Okay, no? So we have examples of talking about the cold-blooded animals. Like you have fish, you have different type of reptiles, uh, you have different type of amphibians. So they are cold-blooded animals. Getting it now? And most of the mammals, including we humans and the birds, they are warm-blooded animals who can regulate their body temperature internally, either by increasing or decreasing the flow of the blood. So that is the thing. Okay, answer these questions also. I'm going to mark these questions as 4, 5, and 6. Also, Priyanka, you were saying something about your syllabus, like you would like to send it. Just send it to the team if you have got it. Okay, let me drop a message to you. Send your syllabus to Learnivio team. Okay, you haven't got it. Okay, okay. Okay. Yes, that is correct. Gauss and Priyanka. Hmm, good. So the maximum minimum temperature of a day are measured with maximum minimum thermometer. The liquid metal, as you guys have answered, that is basically mercury. And use of kink is basically to prevent it from falling on its own, as you guys have answered. Okay. Now, as we know that there are two types of objects, one which allow the heat to pass through it, another which will not allow the heat to pass through it. Imagine there's a fire and you are holding an iron object over this. Say that you're holding a iron rod above this fire. Okay. Now in another place, let's say there's another place who is person who is holding a wooden stick. So which of the person would be dropping? The which person will drop it? Will the person holding the iron drop it, or will the person holding wood will drop it after some time?
The person who catch iron.
Exactly. Why? Why is it so?
Sir, because the heat is transferred.
Getting it, everyone?
Uh,
Because
Iron good conductor of heat.
exactly. You also getting it now. So because what basically happens here, the particles of this iron object now, it starts to shake. They will start to collide with each other, and with collision, they will pass on the energy to the next particle. The next particle will pass it to its next particle, and in this manner, from one end to another end, heat is passed on. So this allows the heat to flow from one end to another. So thereby, this is a conductor of heat. But wood, it doesn't allow the heat to pass from one end to another easily, so thereby it's a bad conductor of heat. Thereby iron is a good conductor of heat here. Okay, have you guys answered this one? Okay, I haven't numbered the questions. No, this is seventh one, this is 8 and 9. But the 8 ones for 7 you have answered. Okay, I didn't saw like steel and aluminum is also there. No, huh? All of these. Good. For 8 you have answered. That is correct. Good. And ninth one also you guys answer. What is the range of temperature reading of clinical thermometer? No, Priyanka. Revisit question number 8. Look at question number 8 again, Priyanka. Your answer is wrong. Now it is correct. Good. No, Abu, the first one is correct, but the second one, look at the question again. It's just asking which one of them has a kink in it. Yes, Gauss, that is correct. For the question number 9, that is correct. Okay. And then what about the laboratory thermometer? What is the temperature range reading of a temperature reading range of laboratory thermometer, Gauss? The A option number A, which you have answered, Abu Bakr, is it for question number 8 or 9?
Sir,
Along
8.
with for 8 now. No, it's only clinical thermometer, no? It is asking which one of them has a king. So only clinical thermometer has. Laboratory thermometer doesn't have.
Uh,
Yeah.
Kink is the metal tip or the
No, that
thing that prevents the mercury to follow.
king is that thing which prevents the mercury from falling. This metal tip is called as bulb. Okay, now? And in this capillary tube, there's a construction that is called as king. Okay. Hmm. And for the ninth one, it is 35 degrees Celsius to 42 degrees Celsius. Okay. And talking about the laboratory thermometer, it has a temperature range between minus 10 degrees Celsius to 110 degrees Celsius. Now, which of the following contains mercury? 10, 11, and 12. You guys can answer in the class. I'm going to assign it. Okay, now? Was you will be answering this one, Priyanka, you this one, and Abu Bakr, you this one. Yeah, answer in the class only. No need to write in the chat.
Okay, sir.
The 12th one is conductor.
Good. 10th one
Sir,
is Priyanka.
11th one.
Oh, sorry, 11th one. Yeah. And that is
D. Negative 10 degrees Celsius to 100.
200
110.
or 110. Okay. Good. Good, all of you. Okay. There's one more thing. As we know that there are different scales in which temperature can be measured. So they are as follows. You have the Fahrenheit scale, Celsius scale, and then there is Kelvin scale also. Now look at the respective temperatures. Like the boiling point of water in the degree Celsius scale, we know it's 100 degrees Celsius, and and the freezing point of water is 100 degrees Celsius. That will be equivalent. Like this 100 degrees Celsius, it will be equivalent to 212 degree Fahrenheit in the Fahrenheit scale. And this freezing point, that is 0 degrees Celsius in the Celsius scale, will be equivalent to 32 degree Fahrenheit in the Fahrenheit scale. And in the Kelvin also, it will be as follows. Like 0 degree Fahrenheit, 0 degree Celsius is same as 273 Kelvin in the Kelvin scale. 100 degrees Celsius is same as, or it is equivalent to 373 Kelvin in the Kelvin scale. Is that clear to everyone?
Yes, sir.
And there are different formulas using which you can convert a given temperature from Fahrenheit to Celsius, or from Celsius to Fahrenheit, or from Celsius to Kelvin, or Kelvin to Celsius, or from Kelvin to Fahrenheit, or Fahrenheit to Kelvin. Meaning that you can interchange the given temperature in between these scales. Got the point now? That is the thing. For example, we know that 0 degrees Celsius is same as 273 Kelvin, right? So if there's a temperature of 5 degrees Celsius, so in Kelvin, that will be 273 plus 5, that is 278 Kelvin. Getting it? Got it now? Or if the temperature in the Celsius scale is 100 degrees Celsius, so in Kelvin scale, that will be 100 plus 273 Kelvin. So that becomes 373 Kelvin. So that is the boiling point of water in the Kelvin scale. In the Celsius, this is 100 degrees Celsius, but in the Kelvin, 373. And the same thing you can observe here also. Okay. So is this conversion between degrees Celsius to Kelvin, is it clear? And we can do the opposite also. Now pay attention here. Like if I were to convert 373 Kelvin back into Celsius, so simply I am going to do the following here. 373 Kelvin. How much this will be in Celsius? So I'm going to simply subtract 273 from it. So I will be getting 100 degrees Celsius back. Getting it? So you can convert from Celsius to Kelvin by adding whatever temperature is in Celsius. You simply have to add it to 273. Meaning that if there's a temperature in the degree Celsius, I have to convert this into the Fahrenheit scale. I have to simply add 273. But sorry, Kelvin, I mean to say Kelvin here. But if I were to do the opposite, I have to convert from Kelvin to Celsius. I will be subtracting 273 from that number. Is that thing clear?